Let's talk about a nonlinear equation and how to find the solutions. First, we will talk about one equation and one unknown, and we will discuss several algorithms. But before doing so, we will study in this video one example where such an equation may come from. And we will discuss some problems we have when trying to solve that equation. So, what is a very simple example? A very simple example is the following one. We have a bank account. And on this bank account, on the 1st of January 2020, we bring 1,000 euro to the bank, and then we wait 5 years. But 1 year later, we will bring another 2,000 euro to this bank account. 1 year later, we bring 3,000 euro to this bank account, and then 5,000, and then 1,000, and then we will check our bank account, and on 1st of January 2025, we have 13,500 euro on this bank account. And the question is the following: if we add these numbers, 1,000, 2,000, 3,000, 5,000, 1,000 is 12,000 euro. So without an interest, the bank account would be at 12,000, but it's on 13,500, so there was some interest rate. And we want to reconstruct this interest rate from these informations. Okay, so how can we find this interest rate? First, we have to analyze what's going on. So we have 1 year between 1st of January 2024 to 1st of January 2025. So there is 1 year, and that means that these 1,000 euro are multiplied with a factor q. And q is some number. For example, 1.05. If 5% is the interest rate, then this is the way the calculus is done. Then we have the 5,000 euros, 2 years, so there's a factor q to the power of 2. We have 3 years, q to the power of 3, and so on. So we have these 5 parts. And that means we have this amount of money on our bank account if we would know q. But we do not know q. We know that this is equal to 13,500, and then we have an equation, and we are looking for the q satisfying this equation. Instead of dealing with that equation, we can bring this 13,500 to the left hand side, and we get this equation, and this is a equal to 0 equation, so we can always transform an equation to an equal 0 equation, and that it turns out that this is a better choice. It makes things or analysis more simple. So we need the root of this equation. Which q satisfies that equation? Okay, what do we see? We see a polynomial of degree 5. And we see a function on this function which is monotonically increasing for q more than 0. So the situation is the value of b for q is equal to 0 is minus 13,500. The value of this b for the q is 1 is minus 1,500, still negative. But for a large q, obviously, let's say q is 10, then it's obvious that this is a positive number. So we have negative value for 0 and 1, and positive value for a larger q. So in between there must be some root, some function, some position where the function value is 0. And now, believe it or not, if you have a polynomial and the degree is 5, there is no formula. It is impossible to find a formula finding these roots. You know a formula for degree 2. It's called, in Germany at least, ABC formula or midnight formula. But for degree 3, there's also a formula. It's a little more complicated than the degree 2 formula. There's also a formula for degree 4, but there's no formula for degree 5. And for 6 also there's no formula. There is no formula and there will never be one. Why? How can that be true? Because there are 5 q's in this equation. Count the number of q. 1, 2, 3, 4, 5 ones. And if the unknown shows up more than once, then it's very, very unlikely that it's possible to transform the equation to a q is equal to something. On the right hand side there's no q. Why is that so unlikely? Because in the end we want to have an equation where the q shows up only once. We start with an equation and the q shows up 5 times, and we want to end with an equation where the q shows up only once. And how can we get rid of q's? And the trick is, for degree 2, in Germany we say quadratische Ergänzung. I'm not sure about the correct English term. We can transform a degree 2 polynomial to a degree 2 polynomial, and the unknown x normally shows up only once, and that's the trick. Okay, and there's a trick for degree 3, and there's a trick for degree 4, but there is no trick for degree 5 polynomials. And for many other equations this is also true. It's impossible to transform that. So if we have an equation and we are looking for the solutions, the questions are: is there a solution or is there no solution? For this example, there is no solution, and we want to find out if this is the situation or that is the situation. Is that possible? Is it possible to formulate a numerical algorithm which finds out if we are in that situation or in that? We will see. We will see. Second, is there more than one root? Maybe there are several roots. Okay, maybe you are in the position that there are 1, 2, 3, 4, 5 solutions, and normally in this case you want to find all 5 of them. And if there is one, then you want to find one. But how can you know if there are more solutions? We will see if we are able to do the job in general. Okay. And third, where are the zeros? Where are the roots? Where do they lie? The exact positions we are interested in, and that's what we will do. Let's check our equation we started with, the equation of the bank account, and then we have this function, and this function is obviously monotonic, increasing on the interval 1 to infinity, and we plot it on the interval 1 till 2. And what do we see? We are below 0 for q is equal to 1, and we have more than 0 for q is equal to 2. And now we want to find this position. Okay, this will be possible. This is a good situation, and we will find satisfying answers in that situation. And if we do it by calling MATLAB or Octave, we can zoom in, and then we learn the root is between something between 4 and 5%. Okay, and here it's very easy to do that job.